Let's now go ahead and connect everything up to the Raspberry Pi. The Raspberry Pi, of course, has to be powered off. I just left the connection for the Ethernet, mouse and keyboard, and HDMI for practical reasons. I have here a battery pack to power up the motors, and I have here a couple of motors already connected to a chassis, and of course our motor controller. So first thing to do is probably to connect the cables of the motors to the motor controller. As Ryan points out on his website, there are two ways around if you make the connections wrong, or if you're forced to connect them in the opposite ways. You can do that. You can make changes on the code so that the result is that the motor will spin in the opposite direction of the one that it is, or more practically, you can probably just swap the cables here on the connector. So, but in any case, I will connect. In my case, I will connect the reds on the M and the black on the J, which is written on the silk of the PCB. So here I am. They're connected the same way. I will just push the connector onto the Raspberry Pi. Then I will connect the battery pack, and of course here you have to be you have to respect the plus and minus that is written onto the PCB once again, and the board should be ready. So we can now apply the power to the Raspberry Pi. And then use our charge adapter to make our measurements. Let's put it in a convenient way so that we can actually look at it. There. So it says here now that it's running at 4.93 volts, 95, and it's 0.21 amperes. Obviously it's going to be moving a bit up and down as the Pi starts up, but then we'll see what happens when the motors are running, and hopefully nothing really should be much changing on the charge adapter, as the motors are powered up by this bank and not by the USB. I've now gone ahead and connected to the Raspberry Pi so that we can put some code up and test our motors as we promised earlier on. As I said previously, Ryan has been very thoughtful and provided some code even for testing of the motor controller. It can be found on his GitHub, which I will be placing a link somewhere so that you can get to it. And this is the code that he suggests to run in order to test the motors. Here are the assignment that he makes so that the various pins of the GPIOs are associated with specific motor cable. And he also gives some advice on how to do the troubleshooting of the reaction, as I mentioned previously, which again is to do with code fix or more simply a wire swap. So I've already created our file, which is called motortest.py, which essentially I've just copy pasted the code that Ryan provides. So let's go ahead and test how it looks like. And there it goes, the motors are running. And they're of course running in opposite directions, contrary to what I was thinking. So again, the method to fix this will be most probably to just simply swap the cables that I've showed you earlier on. And I've got distracted by that extremely rookie failure of the cables that I had to swap now, which I have put in the correct order, and I didn't mention anything about the consumption that we were seeing on the charge adapter. So now that I have put the cables in the right way around, hopefully not the wrong way around, but the right way around, I'll run the test again. So they are, of course, going in the right direction now, and notice that the amperes are constant, as obviously the power needed to power the motors is coming from the power bank, as we said previously. Great. So this brings this video to an end. Once again, I really enjoyed playing with the motor controller provided by Ryan of Ryanteck. I really strongly recommend everybody to get one of those controller. It's really tiny, but it really does what it says on the tin. It's very easy to build and very easy to program. So I really hope that you found this session useful. And as usual, that's all, folks, and I'll see you next time.